Welcome back, we're continuing our look at the Incra LS Positioner. Today it's the turn of the Festool CMS with the router module. If that sounds interesting, stick around. I had a comment from one of the Woodgrafter subscribers saying it seems very clunky as an overall fence and the setup time really didn't make it worthwhile. So let's put that to the test. I've got the fence set up on the MFTs if we're using it there, and we're going to reposition it onto our CMS. So we'll start a timer and see how we get on. Stop! So that took 26 seconds to move it from the MFT to the CMS. I can live with that. If you bought the kit that came with the Wonder Fence, then that came with dust collection via this port here. This is just a hollow piece of aluminium, so you can see sucked straight through. That connects to the other side of the Wonder Fence. I want to make use of the Y connector that I bought with the CMS table, and if you've not seen the video on the CMS table, go ahead and check that out. Now, the reason I want to use the Y connector is I like the idea of being able to continue to collect dust from the router itself underneath the table and still collecting dust on top of the table. The problem I have is that this fitting here that came with the Y connector is too small. However, a bit of experimentation shows that the connector that goes into the CT is actually the right size. So I purchased a CT connector. This is Festool part number 202931. Now this one is actually for the anti-static hose. And this silver hose here is not the anti-static hose, but that doesn't matter because I'm only interested in this end piece. The good thing about the Festool system is that all these end pieces are interchangeable. So as long as we're getting something for the 36mm hose that this is, I can use the inserts inside here to connect that piece on. So I'm not interested in these various connectors here that connect it to the anti-static hose. I'm only interested in this piece that connects it to the CT. To fit this, we simply undo this lug here. There's one on this side and there's one on this side, and that just simply pushes down with a screwdriver, separates, keep the pressure on, turn it over, push it down, screw on this side, and then that should pop off. And we'll keep that to one side in case I ever want to reuse this with the Festool system. Inside you can see it's a really simple design. I've got a locking collet here and I've got this threaded piece that just screws on to the hose. I'm going to reuse these, so leave those in position and then this simply clicks on using those same lugs to attach and secure that in place. And now the large end of my Y hose will connect into the Super Fence. The Super Fence comes with an angled bracket, so it also connects into one end of the angled bracket, and now I can secure that, taking the dust directly down into the CT. So the dust collection on this is solved. Now we just need to reconnect the Super Fence to the standard fence. And now I just connect my converted dust hose to the end of the Super Fence. The next thing I want to do is to make sure that these fences here are smooth at the front. I want to be in a position that when I'm sliding material through this, it doesn't catch on that fence. We slacken off all of the securing nuts, including the centre one, and we do that on both fences. We then adjust these black blocks so they are smooth. The black piece is flush with the end of the aluminium brass piece, and once that's in place, lock that down. Lock the centre piece down, and just for now nip up the outside bolts. Make sure the black piece is flush with the end, lock down the centre one and nip down the outside too. Okay, then test with your material. And you're looking for that nice smooth transition. That's just catching a little bit here at the bottom. So I want to move this fence back ever so slightly. Leave the in-feed fence locked and we're going to adjust the out-feed fence. So slacken off all 3 screws a little bit. If you want to move this fence outwards for adjustment, slide the wedge in this direction. If you want to move this inwards, which is what we do, slide the wedge in that direction. So I'm just going to take that down a little bit, not much, just to about there. And then I'm going to lock the wedge down first, and then just nip up the outside nuts, and recheck. And that's now nice and smooth in both directions, and it's not catching, so that's good. Now we can secure all these down into final position. I then just want to zero these little indicators here, and that's just simply adjusting this little white nut, and this tab here allows me to slide the pointer. That's not adjusting anything, it's just aligning the edge of the pointer up with the scale on the black wedge. And I want to zero that in, so should I ever come to adjust these fences, I know I can get it back to 0 pretty quickly and easily. And that's pretty much a one-time operation, and once it's set up, as long as we've got these zeroed, we can quickly bring that back into calibration every time. And to be honest with you, there's no reason why you can't use the Wonder fences anyway on the MFT. Before we put this through its paces, I want to talk a little bit about the elephant in the room. I'm using this with the Festool side extension. In fact, this extension here is known as a Festool VB CMS CS50. And it looks very similar in appearance to the Festool VL, which is the CMS extension that sits on the end of an MFT table. The elephant in the room is, if you do not have some sort of extension on the back of your CMS unit, then the Incra Fence does not work. Let me show you why. I've dropped off the extension and I've just put it on here on the end of the MFT. And if you're buying the CMS VL version, this is typically how that would be configured. So just looking at the CMS in its standalone mode, let's drop the fence on and see what happens. Now the fence attaches okay in terms of the angle bracket still working and holding the square to the table. Where the problem comes in, even with the fence in its fully retracted position, it's covering up the router hole. So this won't actually work if you've only got the CMS table. There's a number of options. The first option is you can go along and you can buy the VL version of the CMS and put that on the end of your MFT table, and then you can put your Incra Fence on this end of the table, and that gives you that area. But bear in mind that the Incra Fence is not long enough using the crown stop mouldings to clamp to here and still be meaningful in terms of your working area, either for the router or for the TS module either. In that scenario, you would end up mounting your Incra clamp further down your MFT. Where you clamp it depends on the length of the Incra Fence that you purchased, but you're now mounting it to the MFT and your crown mouldings will no longer work. There is a plate available that lines up with the holes on the MFT that is purpose built to match up to the clamping position, and there's a great Festool Owners Group conversation about that, and I'll leave some links in the notes. But that takes away the portability that I'm looking for of moving the fence around from MFT to CMS. So if your idea is to do the same I've done and have a portable system so I can use it on the MFT, I can use it on the CMF, etc., then you're going to need some sort of extension. The quickest and easiest way of doing it is to buy one of the various Festool side extensions. And as long as it's increasing in that direction, your working area, then that is going to work okay for you. Alternatively, you could build a small bench 900mm high that fastens to the CMS and then put the Festool brackets at the end of that, and then you're working in exactly the same way. That will take a bit of time, that will take a bit of money. Using the MFT limits, in my humble opinion, the flexibility of the system. So that's the elephant in the room, and if you're going to invest and go down that same route, think about what you have, what you need it for, and ask yourself, is it the right move for you? For me, it was a no-brainer because I already own the VB extension. The first thing I want to try with this fence is edge jointing. If you're not familiar with edge jointing, it's where we're going to take an uneven surface here and then make that perfectly flat to the point where we could glue two panels together. So a typical use here is you want to take these boards and you want to glue them together to give you an extension. And if you can see here, I've got gaps between here because these boards aren't yet jointed. For this, we're going to use a straight cut bit, and you want one that's not too long. The longer this is, the more it will vibrate at the top and will give you chatter, and that will reduce the quality of the cut. The second thing is, try and get the widest one that you have. The wider it is, the faster this spins on the outer surface in relation to the reps per minute of the spindle, and that gives you a smoother cut because there's more cuts as you're feeding the material across. Our bit is now in place, and I've set the height slightly higher than the thickness of the board. I want to offset this fence in relationship to this fence, so I want to bring the outfeed fence forward. Now this scale here, I'm not actually sure what units these are in. At first I thought they were tenths of a millimetre, but they're not. So they could be in thou of an inch, or it could be just an arbitrary scale. So I'll actually measure the difference between this, and I'm looking for around about a millimetre. So you will undo these nuts here, inside as always. And now I slide the wedge over, and I've discovered that 5 is somewhere around about a millimetre. Now to check that, I can come with my calipers, zero my calipers down, and that's give me 1.17 millimetres, even though I'm showing 5 on that scale. So I don't know, you tell me. The good news is that measurement isn't that critical as long as we have an offset of round about a millimetre. So we want to move the router bit to its maximum cut, so that's the cutting edge here facing me, and then slide the fence up. With a straight edge, I want to line that router bit up with the outfeed fence. Let's be about there, and now I can lock that down. And we've now converted our router table into a jointer. And there you go, a perfect edge joint. Now to be fair, I didn't expect that to be a challenge to the fence. It's a very basic thing that we need to do as we create and get larger panels. But the fact it can do it, and it's relatively easy to set up, that's got to be a bonus. To be fair, you can also do that with the Festool fence, so we've not gained anything over the standard Festool setup at this point. But it can do it, that's a tick. So the next thing I want to try is a rebate or a rabbit down the edge of this board. In theory, with the incremental adjuster, we can do this to a tolerance of 0.05 millimeters. So let's zero the fence and see how we get on. I've reset the fences so they're now back to their zero positions, so these faces are level. And I did that directly from the gauge, and I've not checked it. I'm not going to check it. We'll see how well that works for repeatability. I now want to set the widest cut of the bit to the fence. Straight edge, bring the fence forward and lock the fence down. This is now zeroed to the fence, but I want to look at zeroing the scale at the back. Any whole unit will do for this. 20 on that gauge there. If I now move the fence back in this direction, that will give me the depth of cut for the rebate. So I'm going to take this to 21, which is 10 millimeters, and lock that into position. Without even measuring this, this should now give me a rebate of 10 millimeters, because that gap there should be 10 millimeters. I've set this to an arbitrary height, doesn't matter for the experiment, and we'll go ahead and make the cut. And in theory, with no measurement apart from on the Incra system, this should be around about 10 millimeters. And it is 10.28 millimeters, and that's not too bad at all. And that works really well, and that's actually better than the Festool fence. If you remember, on the Festool fence there's no incremental adjustment for both fences, so you're moving two thumb screws and manually sliding it back and two. So that's a lot better. And I also know that I can reset this and come back to that 10 millimeter mark that we made, and I get exactly the same cut time and time and time and time again. So that's a thumbs up, and that's working really well. The next thing I want to look at is parallel dados. Now, it's not unusual on the inside of a drawer to want to put dividers, and you do that by cutting dados across the board. With the Festool system, that's quite hard to get repeatability and get the spacings accurate. But in theory, on this one, I should be able to do a series of channels or a series of dados across the grain, all of equal spacing, and it should be very, very quick and easy to do. Let's have a look at that. I've dropped in an 8 millimeter router bit, and I've just set an arbitrary height so it doesn't go all the way through the board. And what I'm going to do is just to cut a series of grooves through this board at 20 millimeter spacings. The first thing we want to do is to zero this bit, and that's exactly the same technique as before. So I've just zeroed this into a hole number 10, and I want to do 20 millimeter spacings. So the first cut I want to make is 20 millimeters, which would be 12. So I'd lock in at 12 and make my cut. I'd lock in at 14 and I'd make my cut. And I'd lock in at 16 and make my cut. And so on down the scale till I've completed all the cuts that I want to make. So let's give that a go. We started at 10, so we'll come to the first cut at 12, and I'll make the first cut. And there you go, it's about too much drama, a whole series of parallel cuts, 20 millimeters apart. So that's pretty good. That's a joint that we couldn't actually do easily on the Festool system. On the Festool fence, we would need to be creating stops and ways of stopping that fence in set positions, and that would be a bit of a pain. So that's a really good feature that we can do on the Incra Fence. So yes, we can do jointing on it, yes, we can do accurate repeatable rebates on it, and yes, we can do a whole series of parallel dados if that's what we need to on our joinery, and it's all possible on that fence. To be honest with you, all those things are really table stakes, and I'd expect any quality router fence to be able to do that for us. And the Incra does it, and the Incra does it very well. It does it repeatably and does with precision. So I'm really made up that we've now got that functionality into the shop. But what I really bought this thing for was the more complicated joinery type joints. The dovetails, the double dovetails, the through dovetails, the blind dovetails, the box joints, the double dovetails, whatever they are. That's what I really wanted to use this system for, and I want to be able to do that quickly and repeatably across my projects. However, as I've been looking at the system and understanding how it works, that is really complicated. There's a big learning curve to get to the point where we can be proficient to do that type of joinery. I was intending to cover it in this episode today, but it's so complicated that I want to give it a dedicated episode. In fact, I'm planning 2 more episodes in the Incra series where we go and look at those other types of joints. So we'll do the job properly and we won't rush it. Let's really create something that people can refer to if you're really going to do this sort of woodwork for yourselves. That makes more sense than rushing it now, I think. So if you're not a subscriber, subscribe now. Hit the notification button so you don't miss anything. Leave a like, leave a comment, get in touch as always. See you next episode. Thanks for watching.